All right, so we just learned what felt like probably a million theorems about chords. So let's start applying those. In example 2, we're going to find a chord length. We want to find the length of chord TU. So here's our picture. We can see TU is this chord right here. So just some things to note. We can see that we have congruent arcs. Arc RS is congruent to arc TU, which means that chord RS would be congruent to chord TU. We don't know what chord RS is, so that doesn't help us. But if we knew that, then that's where this could lead us. We can see the center of our circle is Q. When we draw from Q to the chord right here, and we get that perpendicular that right angle right there, that it's perpendicular, that's what we call the distance from the center to the chord. Here's another distance from the center to the chord. When chords are congruent, the distance to the center is congruent. So I guess we could mark that in. This 4 goes with that distance, which means over here we have another distance of 4. Now that's not a radius. If you notice, it doesn't go all the way to the edge of the circle. It's just the distance from the center to the chord. When you have congruent chords, that distance is the same. This 5.5 goes with this QS right here. And that is a radius. So we know the radius of our circle is 5.5. We know the distance from the center to either of these chords is 4. And we're asked to find the length of TU. So first thing we're going to do is we're going to draw in a segment so that we can work with a right triangle. So we're going to draw in segment QT. So we go from Q to T, and we want to recognize that QT is a radius. So essentially we're drawing in a radius. Maybe we'll make a note. QT is a radius of the circle. Well, because that is a radius, we know that QT is congruent to QS because all radii are congruent. And we know that QS is 5.5, so that means that QT is also 5.5. So what we have is a right triangle. If we look at this triangle over here, this is where we're heading. We have a right angle. We know from Q to the chord is 4, and we now know that QT is 5.5. So why don't we maybe redraw that so it's a little bit, here's that right angle, here's T, here's Q. I guess I don't know what that is. It's this point right there. We don't have it labeled. But we know that from Q to T is 5.5, that's the radius of the circle, and from Q to the chord is 4. So we're going to use the Pythagorean theorem. The Pythagorean theorem is going to give us that value right here, which when you have a segment that is perpendicular to the chord going through the center, these two segments will be congruent. So if we figure out what this is, we'll just double it to get the entire TU. So here is that x right there. So Pythagorean theorem, we have x squared plus 4 squared equals 5.5 squared. Let's go in and square everything. 4 squared is 16. 5.5 squared is 30.25. If we subtract 16 from both sides to solve for x squared, we get x squared equals 14.25. And then our last step will be to square root both sides. So we get x is equal to about, we're going to do some rounding here, 3.8. All right, so let's just keep chord TU is perpendicular to, I'm going to write the diameter in here because that's coming from one of our properties. It said that if a chord is perpendicular to a diameter, so this is not the diameter, but I could extend it. It's going through the center, and I could draw in a diameter. So when a chord is perpendicular to a diameter, it bisects the chord. So TU is bisected. Which means that X is half of segment TU. So all we have to do to get chord TU is double that 3.8 that we found. 2 times 3.8 is 7.6, and we'll just throw a units on here. And we found chord TU to be 7.6 units.